project is Intelligent Video Analytics in Smart Cities using Edge Computing. Basically, we analyze the video footages captured by traffic cameras in smart cities and use the inference that we get from the analysis for better data-driven decisions by the traffic and the urban planning department of the government. Coming to this demo, we have two parts. In the first part, we show how NVIDIA Jetson works and how the processing is happening in real time, and we'll show the corresponding things in the DB as well. The second part of this demo is we'll show the traffic and the urban planning department and how we are enabling them making those effective data-driven decisions. So starting with it, if you see this is our edge device called as NVIDIA Jetson. So using this edge device, we are doing all the processing, and this is the Raspberry Pi camera right there. As of now, if you can see here, the real-time traffic count is 0 because none of the analysis is started. So even in the database, it's currently 0. So now let's go ahead and start the analysis of a pre-recorded video on Jetson. So if you can see this video, here things are being recorded, being analyzed in real time. It analyzes that it's a person, it's a car, and it's a bus, or it's a motorcycle, and so on. Now, the beautiful part about this is when you come here, traffic count is being updated in real time. So as you can see, these red blocks signify that it's being analyzed here and the traffic count is being updated right here. So if I go back to my demo here and refresh the page, you can see all these counts will be updated and the corresponding. Now let's come to the second use case. In the second use case, we talk about real-time pedestrian face mask detection. So again, if you go here, you can see the real-time counts are 0. So if I go back again and go to the real-time mask detection demo, you could see that the individual counts here are 0. Now, let's start the analysis of a recorded video on Jetson and see how things get updated in real time, correct? So if you come back to this screen, you can see the process. You can see now things are being updated in real time, and if you go to the corresponding database here, you can see people with mask 2, people without mask 5, and total people are 7, like total people. So if you go back to the React tab and refresh it, it will be updated in real time, and you can see the corresponding graphs. So the video keeps on going off and on, and the data is regularly updated in the database. And again, if you refresh the React tab, things are again updated here. So you can see the count gets updated again, and this count also gets updated in the DB. So yeah, that's about it. Now let's focus on the traffic and the urban planning department dashboards. Okay, so now let's start with the second part of the demo, the dashboards for the traffic department and the urban planning department of the government. So for this demo, we basically took 3 different areas with 4 cameras installed there, the details of all of which are here. And all of those cameras have an edge device with them, and they update the information gathered by each of the edge device at every hour. So when we generate this data over the period of time, we use this data for the effective data-driven decisions that we were talking about. So with that in context, let's start with the dashboards. So for the traffic department of the government, the first feature that we have is the effective police allocation according to the vehicle traffic. So based on how much busy a particular junction or a particular road is, we give suggestions to the traffic police department so that they can have their traffic police allocation there. So as you can see, this tells like camera 5 at the first cross Yashwantpur, that's junction 1. This tells about camera 9 in first cross Rajaji Nagar, junction 1, and the first cross Rajaji Nagar, junction 4, and so on. And it divides them based on the time frame, like the first half of midnight to 8 in the morning, then 8 to 16, and then 16 to 24 in the night. So that's how the allocation is according to the vehicle traffic. This is the key to note here, based on how busy the road is. The second part based on the social distancing norms. So the areas which don't have proper social distancing norms and people don't wear masks regularly, as we are capturing the data point, we suggest the department that they can have police people at camera 11 at first cross Rajaji Nagar, and so on, again according to the timestamps. Third, we have the automatic Challan dashboard. Now automatic Challan dashboard is again interesting, though this feature kind of looks separate from what we are doing. But again, this is kind of a semi-automated Challan where they can fill all these numbers and issue a Challan. And another feature, like whatever images that the Jetson will be capturing, we can easily, like for example, we take this image and I click on upload, automatically the number of this image will appear right here in a second. So you can see NH13CD0096, so it automatically identifies that number in this image, and then this number can be used for the automatic challans. All these challans are listed and the traffic police department can again mark it as resolved or unresolved. So all of this is actually DB driven, so if you see this, all of the challans are right there, so nothing is hard coded. Now if you go to the traffic insights, we can see the historical traffic counts, like what's the total number of vehicles, what's the total number of people who were there on the roads, how many of them wearing masks and how many of them were not wearing masks. These are over a day and over all the 24 hours. So if you can see, you can select various cameras and the data will reload. If you select a different camera, the data will reload here. So this gives a good insight to the traffic department about how busy a road is and how many heavy vehicles pass through them or not, right? Now coming to the traffic insights too, so coming to the traffic insights, we can again see the traffic counts of individual vehicles now. So they can see as to total traffic count was 1338 at 4 and the heavy vehicle count was 457. So this gives the traffic police department a good insight as to how they should deploy their police personnel, right? And again, this can be very effective in cases, suppose if a crime happens in the city and it's because of a heavy vehicle, they can easily carve out this area and check out as to at what time the heavy vehicle count was a little more, and they can effectively analyze that particular footage. So coming on to the specific count of people who are wearing / not wearing masks at various junctions, again we can change it according to the cameras. This tells us to people wearing masks at a particular time of the day. This again gives police or the police department or the traffic police department leverage to identify the spots where people are not wearing masks properly and at what time, right? So this was about the traffic department of the government. Now coming to the urban planning department of the government. So for the urban planning department, they need to find out areas which needs better roads. So how we are helping them is, we are telling them these are the areas with maximum heavy traffic. So here is something like alternate routes might be required. We capture the data points for the maximum heavy traffic, and accordingly using our algorithm we calculate as to what are the top 3 areas that needs alternate roads. And correspondingly we have the areas with minimum pedestrian traffic. So a correlation can be this heavy vehicle traffic can be transferred to these areas with minimum pedestrian traffic, and that will kind of improve the traffic flow in the city. So we again tell the top 3 areas, that's camera 1 first cross Rajajinagar, camera 8 first cross Yashwantpur, and so on. So this gives a good insight to the urban planning department. Now coming on to the second point, for the urban planning department, it's very important to see what are the busy routes and what routes basically needs better routing. So here we clearly show what are the busy routes according to the number of pedestrians and the vehicles. So these 3 come out to be the busiest ones and these 3 not so busy ones. Now another important feature that we have here is how the urban department can find out the safe roads and junctions. So if you see, the longer the bar is, the unsafer the area is, because it is the difference between the heavy vehicles and the pedestrians. So we have kind of assumed that if it's a heavy vehicle and less pedestrians are there on the road, the area might be unsafe for children and other public. So that's how this gives a very good overview to the urban planning department, and this might be even helpful to the normal citizens which area is unsafe. So yeah, that's about all these dashboards, and that's all about our project. Thank you.